Good evening. I am Ann Musikowski, President of the League of Women Voters of Central Delaware County. And on behalf of our league, I want to thank you for joining us for our Jeannette Ross Environment Program for 2025. The League of Women Voters is a nonpartisan organization which neither supports or opposes candidates, but does encourage informed and active participation in citizenship, elections, and democracy, and works to increase understanding of major public policy issues and to influence public policy through education and advocacy. One of the ways we help fulfill our mission to empower voters and defend democracy is to offer presentations to inform the public and voters on important issues. In the spring, our League of Women Voters offers a program on environmental issues in honor of the memory of Jeannette Ross, a longtime member of the League of Women Voters, who was a passionate conservationist who worked for years to protect the Delaware River. In a time when, once again, environmental issues are under attack, it is even more important to offer events that focus on our environment. This presentation is being recorded, and a link to the recording will be posted to our YouTube channel and shared with all those that registered for you to share. I also want to thank those that submitted questions, which were shared with our presenter. Debbie Bergen, a member of our League of Women Voters of Central Delaware County, a voter service team leader, and member of the League of Women Voters of Delaware County Environmental Committee, will introduce our presenter. Debbie.
This past summer, I was lucky enough to be invited by my friend to Chautauqua Institute in Western New York. It happened to be the week that the National Geographic was programming the lecture series, and that is where I heard Rachael Miller. The morning lecture she gave with another National Geographic Explorer had moments where we all gasped at the facts of the trash in our oceans and rivers and our bodies, and other moments where we had surges of hope because there were solutions being presented. And we had moments filled with determination to take the personal steps in the right direction. When I approached Rachael to ask her who I should ask for at the National Geographic to find people to speak to much smaller groups than the amphitheater filled with people she had addressed, she responded, "I'll do it. I have family that live around Philadelphia." And I want to say, lucky, lucky us. Rachael Miller is a scientist, an inventor, an entrepreneur. She teaches students and interns and Navy SEALs. She sails, handles research vessels, and robotic submarines. She leads and takes part in scientific expeditions from the Arctic to the Antarctic, up rivers and around harbors. I'm so happy that she is here this evening. I'm sure that we will be glad we spent this hour with her. Rachael, welcome to the League of Women Voters for Central Delaware County.
Thank you so very much for this invitation, everyone. I really appreciate it. It is especially close to my heart to get to speak with you because my whole family is from Philadelphia. I was really close with my maternal grandparents in particular, and they lived in Center City for a while out in Radnor and had a place in Margate with another set of grandparents who are awesome as well in Ventnor. So you're in a place that is close to my heart as well. So it's a triple exciting to get to speak with you. So I'm going to share my screen and make sure that you can see my presentation. And then I just need to grab the chat window. Okay, so everyone warm up your fingers because we are going to start this with a game that I like to call Name That Marine Debris. So there is a piece of marine debris on the screen. This is from a multi-beam sonar, which is sort of like a video camera radar underwater. It's a little bit of a shape. Here's what it looked like through the remotely operated vehicle's video screens. Anyone know what this is? We have some guesses to type in there. Just type it into the chat window. Yeah, yes, this is a lobster trap. We do most of our work in Maine, so more lobster than crab traps. And we do find a lot of them on remote islands off the coast of Maine. Okay, here is another one. This was found in the bottom of Boston Harbor outside the New England Aquarium. Any guesses about this item? It is smaller than a lobster trap. Dryer sheet is a good guess in that it is a textile, but much bigger. Would it surprise you to hear that this is a pair of jeans? You can kind of see the little hem there on the side, on the right side. Okay, we're getting smaller now. This is a little bit bigger than the height of my hand, I would call it. And it is floating in the middle of the water column. Now, this is a tough one. So this is, any guesses? This is what it looks like. Interesting guess when a red Solo cup starts to break up in the water. It has these interesting, it goes vertically. I don't know why it breaks that way, but they all kind of break that way. Okay, this one, we're not talking about the sand, but everything that isn't sand. They are about the size of a bead, but they don't have holes in them. And you might have heard people talk about these. This actually is not a consumer item. This is pre-consumer. Have you heard the phrase resin pellet? Or you might have heard the word nurdle. So these are the raw material of plastic manufacturing. I was on this is in Stinson Beach in California in Marin County on the Pacific, and there must have been some kind of spill or something because there were a lot of these kind of all over this section of beach. They're transported by rail and water. And so these are my mouse before it was a mouse, or your toothbrush before it was a toothbrush. Okay, we're getting there. This is the last one. So it's not the yellow thing, although bonus points if you can figure out what that is. What I am asking you to identify is this stuff. This. It is thread, but it's almost even smaller. This is the components of what threads are made of. This is what we would call microfiber. So this is a thread that we can see with our naked eye is actually made up of what could be hundreds of individual tiny filaments. And to give you scale, the yellow thing is a piece of spaghetti. So this is a little fuzzball of lots of different pieces of microfiber when it comes actually out of a washing machine. So it's magnified with spaghetti. Okay, so I want to give you information about our organization, and then we're going to get into some challenges and solutions. So Rozalia Project for a Clean Ocean is named after my great-grandmother, for whom I too am named, the R's. She came to Philly as a Jewish refugee from it was Russia at the time, is Ukraine now, from near Odessa. And this is named in her honor. And our mission is to protect and preserve a healthy, thriving aquatic environment, not just the ocean, but the lakes and rivers that feed her as well. We use 4 strategies to do our work, which is primarily focused on marine debris. And those are to do data cleanups. We are not just a cleanup organization, but we use data cleanups in order to understand the problem in the places where we work. We do prevention through education programs. We embrace innovation and technology, and we do solutions-based research. We work from the surface to the sea floor. That is a refrigerator floating around the Gulf of Maine that we picked up. And obviously the shoreline is the easiest to access. And I'd like to introduce you to Hector the Collector. That is our ROV, the remotely operated vehicle that we use to get underwater. We don't throw anybody overboard. We use a little robot instead. And it's not just about looking for trash or interacting with trash, but allowing people to see underwater in real time, and particularly in urban harbors, often for the very first time. And this is what I call ROV face. And people of all ages make this face when they see underwater in real time for the first time. This is in Boston, although I have done this work in the Delaware River at the Independence Seaport Museum. I can't say the visibility was very good, but we could see piles of beer cans under there. Our geographic focus is on urban, inland, and coastal waters, not necessarily in one region or one city. We move around a lot, but the majority of marine debris comes from the land-sea interface. The official number is 80%, but in some places it's even more than that. And so we believe that the most efficient and effective solutions will come from the land-sea interface. And so that's where we focus our work. We thrive, like all nonprofits, on really strong partnerships and a diverse array of partnerships, from elementary schools to universities, from funding partners to partners like US Sailing that help us, that allow us to write curriculum and spread it around across wide groups of people, to relationship with National Geographic and Lindblad Expeditions, which I'll talk about a little bit later, which has given me access to some of the most remote parts of the world. And we are optimistic. We're optimistic in the face of this overwhelming problem because we recognize that the collective we made this problem. There is no question about trash in our oceans being anything other than a human-made problem. And we believe that the collective we can get ahead of it again. Rozalia Project operates from a really cool sailing vessel. I don't know how many of you are sailors and you live in a great sailing area. I also taught in Mantoloking, New Jersey for a couple of years in Barnegat Bay. And so you'll appreciate, we have a really cool boat. She is a 60-foot sailing research vessel that we are really proud to have 100% of our house bank power, so non-propulsion power. We get that from the solar panels, wind turbines, and even a hydro generator. And just for a little sailing eye candy, you can even see the hydro generator in the water off the stern, powering everything that we need to have, we're using power for while we're under sail like this. This is off the coast of Massachusetts, and the people that we bring on board are minimum age of 18. We're at about 72 years as our so far top end, but I think that doesn't need to be it. So there's no top end age for us. We love having people, we try to have people in every decade, more or less, from 20s to 60s or 70s on board for each of our expeditions, which are primarily in the Gulf of Maine. All of our work is solutions focused, and I have this kind of in development or always in development solution pathway to solutions. Our area of expertise is in the field side of the foundation of getting to solutions, which is understanding the problem. So our expertise is in field science. And I would say we spend most of our time on the solution side on science communication, education and awareness, on innovation redesign, and to some extent regulation and policy, primarily by providing data to organizations who are well-versed in the creation of policy so that there are regulations that are data-backed. That is what we're after. In terms of marine debris, the three problems that we work on are really arguably the three biggest ones, which are derelict fishing gear, consumer debris, which is the single-use plastics and everyday stuff that we all kind of handle, and then microplastics. Now, I'm going to spend most of the time on the problem in this talk talking about microplastics and some subgroups within, because that's really, I think, where the least is known by the most people and the most new information is coming at us, especially in the last 2 years. And so in order to do that, I want us all to speak the same language. And that means understanding what microplastics are. So really quick definition. There are two types of microplastics in a broad sense. The first we call primary. Those are pieces of some kind of synthetic something that were made that small on purpose in the first place. And examples of that are those resin pellets that you saw earlier. Glitter, most of glitter is plastic. That is a microplastic. The measurement is 5 millimeters or less, and 5 millimeters is approximately half the size of your pinky nail. Uh, it goes all the way down to 1 micrometer or 1 micron, which is like 1/80th of your human hair. And so that's a really big range. It goes from being able to see it with your eyes to not being able to see it with your eyes, which is a little kind of flaw in the system, but that's where we are. And then we have secondary microplastics, which are bits that broke off of bigger pieces. And those take on several forms. They can be fragments, so chunks. They can be little bits of film. And of course, they could be fibers. The fibers in this picture are pretty big. Those are all related in this picture to fishing. But as you saw from the little game we played earlier, microfiber, when I talk about microfiber, really is much smaller than that. So this is magnified about, I think this is like an 80 times magnification of a pinch of fiber that was filtered out of a washing machine load. The problem of microfiber pollution really primarily comes from clothing, although there is an array of other sources. In terms of clothing, microfiber happens when we wear, wash, and dry our clothes. So really kind of in all of the forms of interacting with textiles, microfiber pollution can happen. Now, as far as the problem goes, when we learned about it, and this was microfiber pollution, really is only discovered in about 2011, and it got some a little bit of news attention in 2013. So as far as problem goes, it's pretty new. When we heard about it, it was a problem that screamed at us. It didn't just kind of whisper. We thought, oh my God, of course, when our jeans, the knees go white, that fiber has to go somewhere. I never thought about it, but it has to go somewhere. It doesn't vaporize. And same thing when like a t-shirt goes soft and lovely, but it's really because you lost a lot of the fibers and they went somewhere. So to find out that they were ending up in the environment really inspired us. And we made 3 goals. The goals were to contribute knowledge, so to do as much science as we could to answer questions that we felt would help us to lead to solutions, would help lead to solutions. We wanted to develop a solution, is that what became the Cora Ball. And we wanted to inspire people from the myriad industries that this problem is involved with to learn about it and to apply their considerable talents and intellect to help address the problem as well. So to understand the problem, I want to give you some more information to fully understand the problem so we can get to the science and solutions part. So this is going to get ugly. Just hang with me here. As far as the magnitude of the problem goes, the most work really has been done as it relates to washing machines. And it has been found that a single garment could produce nearly 750,000 individual microscopic, can't see it with your naked eye, pieces of microfiber, and that's per garment per wash. And so this similar kind of thing is happening in dryers and also while we wear our clothes, but those are less, we have fewer hard numbers on that. As far as what happens when this stuff ends up in the environment is that it's very what we call bioavailable, which means it's so small, it is out there and it can be taken in. Like something huge isn't very bioavailable, like a dumpster. There's not a lot of animals who could eat that or be really particularly affected by it in terms of ingestion or inhalation, but microfibers it can. And it is now known that over 1,300 species have been found with microfiber or microplastic in their bodies. These photographs are from a study that was done just to see if plankton could, this is in a lab, take on microfiber and microbeads, and in fact that they can do. Now, in terms of the dangers that microplastic poses to the creatures in our oceanic environment, they're twofold. One is physical. That means that if you're very small in particular, a fuzzball of fiber or a bunch of small microbeads could fill your tiny belly with something that's not giving you nutrients and cause small animals to, say, starve with a full belly or not be able to do what they're supposed to do, have strong young, or do their vertical migrations. It also can cause inflammation and other types of blockages. The other component of danger for creatures has to do with the chemical side of plastics and microplastics in the water. And that happens in different ways. That is from transfer of additives and kind of things that are part of the plastic, but also a phenomenon that persistent organic pollutants like PCBs, PBDEs, which are flame retardants, and the like, they exist in the water, but they tend to stick onto marine-borne microplastics. And then when creatures ingest them, it has been shown that they can unstick from the plastic and end up in the tissue of the creatures. And so that is a worry. And then we also have other items like, in terms of the fibers, they can be vectors for other types of chemicals related to the fashion and the textile industry that we wouldn't want in the water. So that's happening. It's now important to consider what the effects are. There's a lot here, so I'm going to break it down. And I am going to, in the follow-up that you guys will get, I'll have links to these papers, all the papers that are cited in here, you'll get a link to. So this one study did a literature review, and they found out that creatures in these categories, as represented by the ones in red to the left, experienced one or several could experience one or several of these types of effects, everything from a behavioral effect to mortality, when they were exposed to these plastics. The situation, of course, is that what they eat, we eat. And so the most recent study that looked at seafood specifically was done just last year. It was published last year. It was one done in the Pacific Northwest from Portland State University. And they found that 99% of all the fish that they looked at, and there was a combination of fish from fishing vessels that were fishing for the market and fish that were purchased at a market, 99% had microplastics in them. And of that, 82% were fibers. Now, moving away from the sea creatures and creatures that may be food transferring into human diet, it does go beyond. I actually don't eat any seafood, but that doesn't mean that I am not part of this, because it turns out that microplastics have been found in a variety of our fresh fruits and vegetables, particularly ones that grow in the ground, like carrots and potatoes. But they also have been found at even higher numbers in particularly processed foods. So that's for different reasons. Sometimes it's in the handling, like with tofu, or those are chicken nuggets. I don't know if those are obviously chicken nuggets. They have been found in foods because of the packaging. So that's plastic linings in canned food, plastic bags around bread, or the top and bottom plastic containers related to like freezer meals and that kind of thing, as well as in relatively highly handled sort of condiments like honey and salt. And it's not just our food that is having an interaction with these microplastics, microfibers in particular, but also beverages, from sodas to tea, though it's really mostly the tea bags, not the tea itself, that is implicated. And it has been found in beer. So it makes sense then to look at the water sources themselves. There was a study done by Ord Media that found a very high percentage of samples from tap water samples had some microplastic in them. And when I say this, I am not driving you to bottled water, because just as much, if not more, was found in the bottled water samples. And I used to leave it at this, but what I realized is that the numbers here are really important to kind of make you feel better about why it's so important to try not to drink from bottled water, because the tap water is actually pretty good. That same study found that there were 9.6 microplastic pieces in an average per liter of tap water in the US, whereas an insane number of microplastic pieces are found an average per liter in water bottles. So those are the citations there. The last bit of information has to do with, okay, so this is in our food and in our beverages. Is it kind of, what is it and how is it, what does that even mean for us? So on this slide, really just need to see that gray is by far the type of plastic, microplastic, that is found in these types of foods, and air is on the top right. And those are fibers. So this is why we've done most of our work on fibers. Or we pay a lot of attention to fibers. Oops. And then we want to know just how many. So we know most of it is fiber. And what are we talking about? Are we having like 10 things in our bodies? But another study found that the numbers are in the 10,000s and more in terms of what we consume on the left and what we potentially inhale on the right. So we're talking a lot of stuff. So, okay. Then the next question is, well, where is it getting? So does it go right through? What's happening? Now, my favorite artist is Matisse. My mom went to Moore College of Art, and my grandparents lived like right there at 30th and JFK Boulevard. So it was right around the corner from the art museum. My favorite museum of all, like the Franklin Institute and the Philadelphia Museum of Art, my two faves. So we're going to use this blue lady as our model. Microplastics have been found in human lungs, heart, throughout our digestive tracts, gums, throughout our reproductive systems in men and women, throughout our blood, in arterial plaque, and most recently in brain tissue. Now that, as of about 2 years ago, was almost all we could say, is that it existed in the human body. But what has happened in the last 2 years has really given us an understanding about the issues related. It's not just like, okay, so what? There's microplastic in us. The way to read this is that these are potential symptoms that can arise from having microplastics in various parts of a human body. The darker colors, or the darker gray, is studies that were done with human organs or cadavers, and the light gray, only mouse studies. So differentiation there. I will include these citations just so you can read a little bit more, but it's not necessarily just accumulation over time. It is also some potential like microbiome disruptions and inflammation that can be on a sort of shorter time scale, which for me, and this is as bad as it gets, just so you know, we've reached the worst of it. It is all solutions and science from here, because we know it's not too late. It is worth protecting ourselves and our loved ones from additional exposure to microplastics as well as our sea creatures. And so that is the work that we're doing. And in particular, as it relates to microfiber and microplastics, we've had the amazing opportunity to do this work so far in some really diverse places in the world. So those are that's our sample bucket flying through the air, everywhere from the Arctic to the Antarctic and the Hudson River. So I'm going to share some of our work. Our signature expedition was to study the entire Hudson River. It's how I got to be involved with National Geographic. They funded a 2019 expedition where we sampled every 3 miles from Lake Tier of the Clouds, high in the Adirondack Mountains, all the way to Ambrose Light, where the Hudson meets the Atlantic. We sampled the air at 2 heights. I didn't even like do that on purpose. That just happened, that picture. We sampled the soil. We sampled the water surface. There's our bucket. And we sampled with this cool device called the Niskin bottle at the midwater column and just above the river floor. And what we found was really interesting. We actually did the surface in 2016, but it was when we went back to include the air, the water, and the soil at multiple levels in 2019 that we got involved with National Geographic. But we found something really interesting. And the reason we did this was because the Hudson is amazingly diverse in its like mountains, rural, agriculture, in New York City with a zillion people. And we thought it'd be a great way to understand, like, what are the sources of this stuff and who's vulnerable, like, where is this really happening? And what we found both times was something really fascinating, is that there was no statistically significant difference in concentration across the entire Hudson River. And looking at these heat maps, you'll see yellows, which are the hot spots, happening outside of New York City. And not just that, but happening right at the top of where the Hudson, like the source of the Hudson, where no one lives. You're not allowed to live there. It's in protected park area, but there's quite a bit of recreation. And so for us, that helps us kind of understand the problem in a way that it is not just about cities, and it may not just be about wastewater treatment plants. But let's dig into what we learned. In order to look at the problem in the big picture, we also are concerned with non-microplastic, but still man-made or anthropogenic microfiber. So these are things like cotton clothing or wool, and to figure out what the ratio is of synthetics to non-synthetics in our waterways, and whether we need to be concerned about both types. Clearly, from a toxicological angle, the plastics are a higher priority, but we are also interested in all of it, because I don't want even my cotton t-shirt in plankton bellies. And one thing that we found out while doing this work is what you can see on this slide, is that even a cotton fiber can leak dye. That's what's happening. That is a cotton fiber from a blue cotton t-shirt, we think, because we think this was contamination, that was leaking dye on our slide. It's crazy. So for some of our results, what we found was really interesting to me. So we sampled the surface, which is the blue, the middle of the water column in that kind of light pink, and the red was just above the river floor. Now, the Hudson River is very shallow for the upper Hudson, so really just look on the right side there. And you can see a very similar amount of microplastics at each level of the river, which was really interesting. And for me, I love this because it means that you could probably do surface sampling only and see if we're moving the needle once different types of solutions are implemented. And the same thing happened in the air. Is for the 2 levels of air, which we were only able to sample from American Promise, we found very similar amounts. So the lower was my inhalation height. I am about 5'3", so that's kind of what us 5'3s are looking at. And then the blue is at about 25 feet up. And again, sort of a similar amount of microfiber flying around the air, microplastics, mostly microfiber in the air. And as far as soil went, there was a big blob down just north of, like, around the Poughkeepsie area, but otherwise we didn't see any real statistical relationship between what we found in the soil or the air or the water, which was super interesting. But what we're really after is understanding the sources so that we can prevent this. This is a particularly hard problem to clean up. So we are looking at it from not just what everyone else did before, which was saying, we found 100 blue polyester fibers, and that's all that people used to say. But here's something interesting. You could have blue polyester fiber from a microfiber cleaning cloth, a bikini, a carpet, and fishing line. And you can't prevent anything if that's all you know is blue polyester fiber. The only way to prevent any of these things is to be able to know that it's from, more likely, a bikini or a carpet or a fishing line. And so we add 3 other categories of identification, which is the shape of the fiber, the presence of this stuff that makes it shiny or not, and the width, which is one of the most important. And in doing that, we are able to identify potential sources. So for that that Hudson River expedition, we found 972 pollution particles, but of those, they fit into about 327 categories or potential sources. And that's now we're kind of getting somewhere. So in terms of thinking about these sources, we also want to know is, well, is there a point source? Like, is there a factory or is there some thing that's just spewing this stuff? Because that would mean we could just go to that source and negotiate or innovate or figure out what we have to do to prevent it. Or is this maybe clothing from multiple diffuse sources, and we need to look at the textile industry on the whole and how we all take care of our clothes? And so we started looking at that issue in terms of how many particles per source. And it's kind of wild to look at this. This gives me hope. So this is looking, the pinks and purples are remote places, the Arctic, the Antarctic, and the subarctic. So what we found there is that there were almost as many sources as there are particles. So like, and not very many. When we were in the Arctic, we found 5 total fibers in the air over like 20 locations, which is awesome news. And they were each from a different source. And to us, that means that we are very far from any potential mechanism of loss. So any kind of, nobody's just spewing it out right there. Whereas on the Hudson and in Long Island Sound, and interestingly in Hawaii, we found much more individual particles per potential source, which means we're closer to the mechanisms of loss. This is all good news to me, because if the people are part of this, we can kind of get there. We can address that. So in terms of mechanism of loss, one of those is dryers. And a colleague and I did a little COVID science 2020 to look at dryers. We realized that snow could help us. And we dried bright pink blankets and then kind of let it spew out all over the snow to see what would happen. And this is what happened. This is 5, 10, and 15 feet away from the exhaust vent. And then those ones in a semicircle are 30 feet away. So it was getting pretty far away. We tried to do it all on days that were relatively windless. So kind of getting around. And what we found is that there's a fair amount of fiber that's coming out of our dryers. And there's just some examples. It depends on your dryer. The top one is my colleague and friend in Idaho. The bottom one was mine. Interestingly, I have a newer dryer than her, and I had more coming out. And then her lint trap, which is on top, caught more than my lint trap, which was smaller. So that's another interesting result. We think there's great hope here. One takeaway is definitely clean your lint traps, not just to keep your house from burning down, but also to reduce the number of fibers that can bypass the lint trap and go straight into the environment. So that's a pretty easy action right there. In terms of them getting out into the environment and then moving around, some of our work in Arctic Svalbard helped us kind of understand the potential connection that we all, especially on the East Coast, have to where our fibers could go. And what we found, fascinatingly, is that in Arctic Svalbard, where there's like 1.5 towns, virtually no people, and the towns are over here. You can see not where we sampled. We found hotspots of microplastics at these 2 orange places. And that's also compared to the west coast of Norway, where there's not a lot of people. Red is people, but there are still more. And yet that's where our hotspots were. And we thought about that and like, that doesn't really make sense until we overlaid the currents. And check this out. So here's Svalbard, Arctic Svalbard up there. Follow the pink. And the pink kind of just is part of the North Atlantic Gyre. So we've got the Gulf Stream that comes up from Florida past you guys to kind of Gulf of Maine-ish, and then heads east, and it actually dead ends in Svalbard. So to us, that is a connection, that actions that we take, especially on the east coast of the US and the British Isles, they could have consequences to the walruses and polar bears up there. Okay, so CSI for the Ocean is a global citizen science microplastic mapping and monitoring project that we are running in partnership with National Geographic. They helped us deliver kits to schools in Hawaii so that students can do this. These are the kits, and it's all done with forensic methods so that we are looking to make it as accessible and inexpensive as possible. And our partnership with National Geographic and Lindblad Expeditions has us executing the same work with people of all ages from all over the world. And that's what we're aiming for. We have an app in development. So this is something you all can do, is take samples in the Delaware River or the beach off Ocean City or Ventnor, and or in the, would be really interesting, in those bays on the inside, and to do that. So stay tuned. We are working. When the app is ready, we're going to unleash this, and believe me, I will be coming back to you guys. As far as solutions go beyond understanding the problem, this was our second goal, was I introduce you to the Cora Ball. The Cora Ball is an in-drum device. You put it in your washing machine, and it does two things. One, it reduces shedding in the first place. It helps your clothes last longer and keeps them from shedding as much as they would without it. And it can also tangle up some of the fibers that do shed. It depends on a lot of factors, how much fiber you get in the ball. Like having a lot of hair, like I do, kind of helps the hair, kind of weaves it up. But they are always helping to keep the reduced shedding. They were inspired, the shape and the method is inspired by coral itself. And so it's called a Cora ball, because we didn't want to call it a coral ball because that might be confusing. Because coral does what we need this thing to do, which is catch small things from moving water. And you just throw it in the washing machine or drop it in. It works in any kind of washing machine. And this is what it looks like when you do catch some fuzz balls. It looks like hair to your naked eye, or any sort of just blob of lint. But when you put a digital microscope on it, what you realize is that what's sort of gray into your eyes is actually a bundle of microfiber. That's a piece of hair on the right. So you see how small this stuff is. And that little fuzzball that we were just looking at is the stubby pencil showing right there. So that's certainly something that is, this is one of those solutions that is collective power. It helps with you with your own clothes, which is great, but together, people reducing shedding, whether it's with a Cora ball or with aftermarket filter, it's something that makes a big collective difference. Now, to wrap up the microfiber part of all this, we are trying to use the data and the knowledge that we're collecting to figure out if there are point sources in the world. I love this data visualization, sort of mappish, that shows us maybe places in the world where there's higher amounts of textile production, and perhaps there might be more microfiber loss there, but we won't know that until we have similar methods happening around the world. But there haven't been a lot of point sources found yet, though we haven't, the collective scientific we, not just us, sampled everywhere. But if there aren't, or in the absence, or in addition to there being point sources, it is most likely that as far as clothing is concerned, we also have multiple diffuse sources. And if that's the case, then there's a couple ways to kind of go after this problem. And one is to understanding our clothes better and to reduce the shedding in the first place. So that means making more resilient clothing, or for now opting towards more resilient clothing, and then making sure that we can still have soft things that don't fall apart. That ultimately would be a great outcome. And then another would be to investigate the innovations related to alternative materials to make our textiles. And so that would be less petrochemicals that have to go to landfill, and more of a naturally derived and bio-benign on the back end type of a textile. And there is progress on that, which is encouraging. So all of our work isn't just about microfiber. Does anyone know what this is? Are you thinking, oh, that is a disgusting close-up of a plastic cutting board? You are right. That is a plastic cutting board. That is a huge contributor of microplastic to our food. And so the Coral Ball is not actually our only product. We wanted to figure out where we could reduce people's exposure to microplastic in multiple ways. And another way is by using wooden cutting boards. Whether you use ours or not, it doesn't matter. But this is one way you can make a really big difference in the exposure that you're between your food and microplastics is to switch over to wood. So there's bigger microplastics too. And this is something that you guys can do, especially walking on the beaches of New Jersey, is to do a microplastic walk. Now you're going for the stuff that you can obviously see. I like to put them in little vials. And you can see that there are some unifying objects in these. Does anyone think in your heads, if you were going to say, okay, one of these vials is from Hawaii, where do you think it would, which one it would be? If you are thinking it's number 2, you're right. And it's number 2 because can you see those are so bleached? They're completely washed out, they're weathered, they're nearly kind of similar colors. It's because Hawaii is more of a sink than a source. And those microplastics had to float the majority of the Pacific Ocean in order to wash up on the windward side of Oahu. What you'll find when you walk the beaches of the eastern seaboard, in particular New Jersey, and I actually have one of these from Mantoloking from last year, is it looks a little bit more like Alicante or the Mediterranean, or you can see Guincho Beach in Portugal. A little bit more like that, with some similarities. It turns out that resin pellets connect us all. And you'll find some on your beaches. They look like beads, but without the holes. And that means that there's been a problem with transport somewhere, that there's been a loss in transport. You also may find sticks that are tempting to think are lollipops, which is what I thought. They were some kind of lollipop stick. But doing a little bit of research, I found that they're actually, especially when you can see little hash marks on either end, they're plastic Q-tip sticks that the cotton has dissolved in the ocean and the sticks are left over. And it turns out that there are a lot of countries, especially in Europe, that are still using these. And they are not they are often flushed and not handled very well by septic or wastewater treatment plants. And so they're often spilled. And I found tons of them in Portugal. So, but whatever Portugal's is washing up on Portugal beaches could be washing up on New Jersey beaches and washing up the Delaware as well. So that would be interesting if you guys, some of you do this work or these microplastic walks and collect some, to send me some photographs of what you find. Because doing these types of data cleanups or microplastic walks and recording or noting what you find can lead to action. The example I have most recent is in dock foam. I don't know if any of you have seen this kind of unencapsulated dock foam in your area. We see it a lot in New England. It's ridiculous because it makes the foam very vulnerable. Here's what we found on the shores of Lake Champlain. Here's what we found in the Gulf of Maine, actually just south of Southwest Harbor, where one of your colleagues is. And in the end, we worked with the Conservation Law Foundation and we were able to get a ban on unencapsulated dock foam, bit buried on page 60 of 65 of a bill that happened last summer in Vermont, but it's there. And this is a very clear line of action from data cleanups, walking on a beach, finding this stuff, recording it, taking pictures of it, and bringing that information to policymakers. So I'm going to accelerate here a little bit and talk about our education programs, which is not just cleanups, but going beyond. Like we said, data cleanup. So we dump it all back out. We write what we find. We talk about, this is a behavior change game, we call it, to talk about what does inspire people to change their behavior. We talk about what it takes to bring an idea to reality. We have participants join together with similar ideas or similar focuses. We share our experience with the Coraball development. We even have traveled with a 3D printer so people can make their ideas come to life. And then we ask that they figure out how to explain their ideas, that they engage in what Nat Geo calls science telling. So I'm going to do a really rapid fire share of some of my favorite solutions from around the world, because it's definitely not all about us. There are some amazing things happening in education. There's marine debris education happening all over, and I'd be happy to share. There's incredible messaging campaigns like Beat the Bead, which are successful in getting microbeads banned. And ones like this one, which are still working on it, but hopefully having balloon releases a thing of the past will be something that we can look forward to in the future. I think art can be an incredibly powerful tool, whether that's reminding people that storm drains are connected to the nearest waterway, to using marine debris itself in front of the sea like there, or this is a marine debris exquisite piece of art that a colleague of ours, Cindy Piesro, who lives in Long Island, did. She even brought her technique and skills to us, and we built inferior versions of her marine debris art. It was way fun. We had a sustainable clothing designer come with us in 2023. Her name is Runa Ray, and we built a dress entirely out of fishing line that we found on a remote island in the Gulf of Maine. It was like the traveling pants. All of us looked good in it. It was crazy. It was really fun. I have more pictures of that. I know this is dear to your hearts, and it's so important, if not perhaps one of the most important ways to move people is regulation and policy, in particular if it's data-based, although you do have some crazy things like this. This is a map that shows bag bans, but it also shows where there are bans that ban bans, and then it shows where there are places that ban the banning of bans. So that's complicated, but our reality, although that's changing. We have Ocean Conservancy producing things like this, an international plastics policy playbook to help people all over the world address the problem. And then we have innovation and redesign, like using bio-based materials. These are algae straws. We have people like this. This was a great guy. So what we have here is a meat tray. Watch what happens. Boom. So instead of having to use meat diapers, which are those like extracted plastics to landfill, he figured out a way to just have recycled and recyclable PET plastic instead of styrofoam and a meat diaper. But it doesn't have to be some kind of big innovation. Here's a coffee shop in Napa that just uses spaghetti instead of stirrers, plastic stirrers. And then there's some infrastructure solutions that I love. This is, have you heard of the Great Bubble Barrier? So in Amsterdam, where the waterways are navigated by a zillion boats, and they need fish and boats to move back and forth, but there's tons of trash. And so this company, the Great Bubble Barrier, figured out that whales use bubbles to herd fish. And if you can herd fish, you can herd plastic, because they can't even swim. It can't even swim by itself. And so they put a bubble maker underneath the canals, and the bubble net diverts plastic into a catchment area. It's brilliant. I love it so much. Fish and boats can go back and forth as they need. But then if you've been in Baltimore, there are places where there are no boats or anything that needs to go back and forth. The fish can go under this. And Mr. Trash Wheel and Professor Trash Wheel are in Baltimore Harbor, where booms feed them. And when the rains come and the water moves, the water spins the paddle wheel that moves the conveyor belt. And that is what was collected in a year in a passive, brilliant piece of infrastructure. There's some system-wide and community level changes where this is in Durban, South Africa, where it's hard to kind of go after the trash until you address the human situation. And so there are some incredible organizations who are engaging people in communities to lead. The people are in the townships to lead the in a way that upskills their professional situation and helps everyone in the community while addressing the problem. And lastly, science itself can be a solution, whether it's using the marine debris tracker or looking at scholarship that indicates where this stuff might be coming from. And the story that I have here is that you'll see that Indonesia was one of the top 5 places where marine debris was leaking. And I was in Jakarta for a marine debris expedition program, and we met with this, he's a minister of marine affairs, and they found out that like they saw that they were getting really bad press for having so much marine debris. They looked internally and they saw this river. That's what it looked like about a year and a half after that paper came out. And this is what it looked like after they decided that that wasn't going to work for them, that Indonesia is a place of marine tourism, and they cleaned it and it remains that way. So that's science did that. So I want to leave you with a couple bits of information. You're welcome to screenshot this. And if you'd like, I could even include these in follow-up. So here's a bit of a summary that not all plastic is bad. We're using it now. So much of it enables so much of our lives. However, the plastic that leaks into our environment can be harmful. It can be harmful to the marine food web. It can be harmful to us humans. And we are not always right about it just being okay. And that action for this problem solves multiple problems, including climate change. So if some of you are kind of thinking, well, what can I do? Let's go first with marine or with microfiber and related to our clothing, because we know that fibers are the primary thing that we're inhaling and ingesting, and that clothing makes up the most of the microplastics that we are finding in the marine environment. So firstly, we can take care of what we own. So by making less microfiber pollution. It goes hand in hand. So whether you use a Coraball or not, there are free ways to do it. And that is use cold water. Hot water makes more fiber. It kills your clothes faster. Wash less. So that means doing some spot cleaning. Here's an interesting one. Doing a 3/4 to a full load causes less shedding than a very light load because the clothes don't do as much. There's less friction between garments. And then when it comes to drying, where it's possible to hang dry, we're all from the Northeast. We can't put our clothes outside all year. So that's just, I use my dryer for sure. But when it's possible to air dry, do it. Where we can collectively slow fashion down and encourage our people around us to slow fashion down, it will make a difference. This is where we also start to solve for other kinds of problems like climate change. And so examples include buying less, buying the good stuff when you can, when it's possible. If you can't buy good stuff new, to look for the good stuff secondhand to make it more affordable. And to think twice when we realize that we're buying for something other than need or great joy. Great long lasting joy. Do it. Buy the dress, buy it, wear it, love it, like all the time. But if it's something to fill a little hole, then let's think about better ways to do that. And we asked that to we asked a bunch of first graders once after a little presentation if they really needed balloons at their birthday parties. And they're like, no, we don't, which obviously was the right thing to say. But then I asked, well, okay, your parents are going to ask this. If you're not going to have balloons, what would you like? And a little guy throws his hands in the air and he's like quivering with excitement. And I point to him and he screams, puppies! Like, I don't need balloons. Bring puppies to my party. So there you go. Just some ideas. Although the kids also said art and kittens. And one kid just said my friends, which I thought was the sweetest thing ever for a 5-year-old. Other solutions are to support innovation so we can keep finding ways to make our textiles more resilient so we can, again, still have soft and fuzzy, but without the fraying, and also to look at alternative materials. And then enact policies, support science that is the foundation for it, because a lot of people won't do this without a regulation, of course. All of the data that we have found really does, as far as microfiber and microplastic goes, particularly microfiber, does give me hope. These are some Gen 2 penguins. I actually took that picture with an underwater, like a GoPro that I just shoved in the water. And the reason I have hope from this work that we've done is because we are finding that there is less microparticle pollution in Antarctica. In fact, Antarctica has the least of anywhere I've been. And thank goodness, that means there's still time. There is still time. It's clothing, mostly from clothing. And again, for me, that's good news. That's better than there being 25 different industries contributing to this in a huge way. There are multiples, but if we can address it at that, it's better. And that we need some innovation, but there's already, and I've shared some of them, roads to doing better, and we just need to take them and to bring our people with us. So if some of you are still kind of hung up on their the issues like with the Matisse and the human body stuff, I've got some ways for you to reduce from a health perspective. So the tap water thing, our tap water is really good compared to water bottles. Just I sat next to the one of the researchers who did the Columbia University study on the micro and nanoplastics in the water bottles. And this is a quote he said to me. He said, after doing that study, he won't let anyone he loves drink from a PET water bottle. Ugh. Try to make this a rule not to use plastic in the microwave. That has been shown to be a transferer of plastics and other stuff we don't want into our food. So just take the stuff out of whatever pouch or thing and put it in glass or just a plate, ceramic. Use wood cutting boards. We've covered that. When you can, switch to glass at the grocery store. So things like, peanut butter, there are choices. There are really delicious peanut butters in glass, and same with olive oils and stuff like that. As far as tea drinking goes, there's great. I've really tried to mostly switch to loose tea, and I have this little like tea dinosaur. It's cute to put my loose tea in. Where you can avoid highly processed foods. Again, it's just the handling. Just the more food gets handled in some factory by people wearing gloves and on plastic cutting boards and with plastic stuff, the higher the likelihood of a microplastic transfer. I am not a believer in everybody's in saying anything like no more plastic clothes. We need them. This is I am an outdoor sports person in the winter, and we do need synthetic clothing. I don't think we can feed and clothe the whole world on our agriculture. However, when possible, I do think it makes sense from a health perspective to move towards wool thermals, to move towards natural materials, especially on your upper body where you breathe. And then to think about saying, please don't throw your fleece away after listening to this talk. Like, solemnly swear, I will not throw my fleece away tonight. Keep your fleece, but strategize about it. Wear like a wool turtleneck on the inside, so that's what your face gets, and wear a low shed soft shell or hard shell or something like that on the outside. So your fleece can do its thing, keep you warm and cozy, but without spreading its little bits of polyester into the world because you're wearing a low shed on the outside, and without you necessarily breathing into it because you've got wool or cotton or something on the inside. And hopefully that will serve you well. I am going to skip the next section with a quick stop share. And then I'm going to switch to my end slide just because it's kind of late. And let's see if I can do this without Okay, I'm going to share it one more time. Okay, here we go. And I'll also put this information in the chat. We have a special for you, just for you guys. Coraball, buy one, get one, 15% off, or buy any Coraball anything and get a second of that for 15% off. I'll also put this in the chat. And that's how you can keep in touch with me. I will also put this in the chat and the follow-up. I realize I've taken all the time, but I'm happy to stay if any of you are to answer questions. And if people have to go, I want to say just a really big thank you for having me and letting me share this information with you.
Thank you.
Can I just say thank you from all of us. I learned a lot. Did you guys learn a lot? I said thank you for your research and for sharing your research and your solutions. Um, do you have time to stay and answer a few questions?
Oh, absolutely. It's the least I can do because I got so excited when I was preparing it. I realized I probably included a few too many things.
Well, you are a very good presenter. I would say Debbie, who found you at Chautauqua, did a good call there.
I appreciate it. So I will have a look through these the comments. I totally get people have to leave. Oregon's passing a bill to eliminate small food plastics to help keep a cleaner beach. I love hearing that. And I can add that Oregon gets another big thumbs up because they currently have a microfiber bill up to require filters on washing machines. Because ultimately that is the another way. Like I hope the Coraball becomes obsolete sooner than later, because hopefully what happens is our washing machines will do the job of stopping most of what would otherwise wash down the drain. So, so yay, Oregon. And I just put a bunch of links and things. We'll send those away to you as well. So don't worry about it, but you can, there's some stuff there. Okay. How will projects be affected by the current federal funding freeze? And so with Rozalia, so I'm very, well, it's good and bad for us personally, which is probably going to be the case for a lot of the people with whom you speak. From a National Geographic and Lindblad angle, thank God I am working with them. National Geographic is a spectacular funder. Just so you know, their partnership with Disney is fascinating in that Disney pays for all of their overhead, 100%.
Wow.
Every single penny that is donated to National Geographic Society goes to explorer-led programs like mine.
Wow.
And it's incredible. And so what that means is they have enough to support us without needing the federal government, which is incredible. And so knock on wood, I will be going to the Arctic in June and July, to Svalbard again, Greenland and Iceland to continue the CSI for the ocean work. And I've applied and hopefully I'll hear soon to go back to the Antarctic. So on that side, things are great. On the Rozalia Project side, it's absolutely terrifying because we're in one of those positions where funds have been both appropriated and I think the official word is committed, but they haven't been transferred. And that is 7/8 of our summer this summer. We are proceeding as if it's going to happen, like we're going to get that funding. I hope it doesn't vaporize. And unfortunately, I'm sure you all realize that just there's so much uncertainty that there's just all I hate hope as a strategy. I
Mm.
mean, like it's terrible. It is a terrible feeling to be like, I think so. Our board of directors is kind of working on like a plan B if all of a sudden we hear that 7/8 of our summer funding is going to go away. And our executive director, Ashley, who's wonderful and who's holding it together incredibly well, is proceeding as if it's all going to be okay because this has been committed. It is year 3 of 3. It's a coalition. We're working on derelict fishing gear in remote islands. We have so much great data. This is like the last piece. So yeah, so that's kind of where we stand on that. The Brita question. This was submitted before, which I really appreciate. So I had a chance to do a little research. Okay, so here's what I found out about Brita is that, well, I found out a lot. So it turns out there's an organization that I was unaware of called the National Sanitation Foundation, called NSF. When I first saw it, I thought it was the other NSF. But it's not. It's the National Sanitation Foundation. And it turns out that they have a certification standard that filters can be certified under to stop microplastics, and that the Brita Elite filter stops microplastics between 0.5 and 1 micron. 85% is the standard. So if a filter achieves 85%, stopping 85% of microplastics down to 0.5 to 1 micron, which again, a human hair is somewhere between 80 and 100 microns. So this is very, very, very small. Then it gets certified, and the Brita Elite has that certification. So that's awesome. But not all Brita filters do that. So the pitcher doesn't, and whatever the ones that are not elite. It's something called the Brita Hub does it as well. So that was a cool bit of information. I appreciate that question. Someone suggested we should tax plastic. So interestingly, as far as I know, there are still subsidies on gas and oil production. And for me, my first thought was let's just take away the subsidies rather than tax it, because then it feels like the more right people pay rather than the sort of more wrong people pay. That, although maybe in the end we all pay for it anyway, but still, at least on the front end, we probably all still pay for it anyway. But right now, the kind of real situation is that virgin plastic is less expensive at the industrial manufacturing level than upcycled or recycled. And that just seems wrong to me. And that's because of subsidies. And so whether it's sort of taxing plastic or removing subsidies, I think this upside down situation where the virgin material is financially or economically favored, I think there is an opportunity for a government. My guess is not this one, but for that to get toppled a little bit, it would be good. But who knows what's going to happen with all these tariffs and so much plastic stuff coming from China. So like so much of the plastic in the US, plastic items already made, comes from China. There's quite a bit of resin pellet production that happens in the US. And I don't know what's going to happen. The plastic production in the US went up a huge amount. I think was it the winter of 19 to 20 when Houston and Texas had that humongous freeze. You guys remember that? Like big weather. They lost power for like a long time. Well, fascinatingly, that was a direct cause of a huge rise in the price of resin pellets in the US, like of raw material for plastic manufacturing, because they had to stop production. And so there was a lot of demand and not a lot of supply. And then COVID happened and the rest of it, and the price hasn't come down. So, yeah, I mean, I hope what the result is with the tariffs, maybe something good. There's just less plastic crap that happens. I don't know. I'm trying to look at the good side.
Can,
Other-
can we wrap up with a question that we like to ask our guests? What can we do and what suggestions do you have? The last question that I just put in.
I totally appreciate this question. All right, so for the young, aspiring, or any age aspiring environmental advocate or inventors, well, I think on the inventor side, if people or people, if you have an idea or your people have an idea, there's some incredible incubators, accelerator programs, classes at universities and colleges, and things like that that help people develop ideas. And they do it in different ways. Some ways you don't have to pay to be part of it. Some ways they fund you. You don't have to give equity away in all of them. We used a grant from the Schmidt Marine Technology Partners. That's Eric and Wendy Schmidt's uh, philanthropic one of their philanthropic arms specifically dedicated to marine technology, a grant from them to do our R&D, but then we used Kickstarter to actually get going, a sort of we were approached by venture capital in a very like we want equity kind of a way, but we were like we need to give back to Rozalia Project because that's where all this started, and so we used Kickstarter. And there are some creative ways, and if you do know someone who's got an idea, I would be happy to share our experience. So so that would be something on a bigger picture. Um, as you can imagine, I am a believer in lots of littles make a big, is the way I kind of say it, is that the little things that we all do make a difference for sure. And people see it. Even you don't even have to tell people. You just pull out your little wooden utensils when you're out to whatever lunch with a friend. You don't even have to talk about it. It's contagious. Or you can talk about it. It's even better if you do talk about it. But I do think that that is something to always keep in mind is lots of littles make a big, but also that large corporations and the people who are kind of upstream of consumers, they have a lot of power too. And where we can inspire the deciders, whether they're in municipalities or state government or it's so hard to talk about the current federal government as being inspirable on this one. It's hard to know, but certainly at other levels in smaller areas. And, it just sometimes doesn't take a lot of little changes to make a big one. And just one quick example is the microbead. Are you familiar with microbeads? So they were in like personal hygiene products, little tiny plastic beads, toothpaste and stuff like that. And it was like Illinois first got them banned at the state level and then Vermont. And actually I got to do Senate hearings, like committee. I spoke in committee, which was cool for me. I'd never done that just because we had found them in Lake Champlain. And from a supply chain angle, 2 states was all it took because it makes no sense for Procter and Gamble to send plastic-free face wash to Vermont and Illinois, but send plastic encrusted face wash to everybody else. It just became easier for them to make the change in their supply chain. And so in the end, they fought it in a different way and they kind of it's not so much that they crumbled, but it was very clear that it needed to be a national thing. And one of the last things that President Obama did was sign that into law. And other countries have had the same. But that, in a lot of ways, it only took 2 states. And then the supply chain reality took it over. So I suppose that those are my bits of advice. And be part of your group. That is also part of my advice is to do what you guys are doing. You're already doing it, but to keep your heads up.
Rachel, thank you so much. I thank you from all of us. And I know that you're going to be sending a lot of Cora balls and Cora boards to southeastern Pennsylvania.
Awesome. Awesome. And yeah, we'll send lots of follow-up information and links and things like that. And I really am happy to answer direct questions. You'll have my email here and also in the follow-up.
All right. Thanks, Rachel. I
Thank
really
you
appreciate
so
this.
Thank you for hanging in there and for having me.